Good morning, dear student. In today's lecture, we are very much interested in the important point of our syllabus, that is the ligands which having a pi system, extended pi system. So how these p orbitals are involved in the bonding, and how the bonding anti-bonding molecular orbital is formed in case of this pi system ligands. So if you consider the ligands having extended pi system, these ligands are classified into two types. One is linear and another is cyclic. So there is a cyclic system and there is a linear system. So in today's lecture, we are very much interested only in linear system. So the very common example of this linear system is your ethylene. So we are very much familiar with this ethylene, that is CS2 double bond CS2. Pi bond is formed, and how this pi bond is formed by the overlapping of p orbital we will discuss in these lectures. So if you consider this ethylene molecule, a single pi bond is formed. A single pi bond is formed. Single pi bond is formed by the interaction by the interaction of two 2p orbital, by the interaction of two 2p orbital on its carbon atom, on its carbon atom on its carbon atom. These interactions of p orbital result, the interaction results into one bonding and antibonding, one antibonding pi orbital. So if you consider this is your ethylene ligand, so a single pi bond is formed by the interaction of two 2p orbital on its carbon atom. The interaction of this p orbital results in one bonding and one antibonding pi orbital interactions. So how it is actually happen? Let us discuss it. That is how these p orbitals overlap and how there is a formation of bonding and antibonding molecular orbital. So we know that the electrons having a dual nature, that is wave as well as particle. And if you consider the wave, then it is denoted by the function that is psi. So whenever we consider the interaction, we consider these interactions are represented by certain function, it is known as psi, and this function is nearly equal to the number of carbon atom. So if there is a two carbon atom, then there is a two function. If you consider the ethylene molecule, there is a two carbon atom, then there is a two wave function, psi 1 and psi 2. So out of that, one is homo, highest occupied molecular orbital, because it is bonding interactions, and one is LUMO, that is lowest unoccupied molecular orbital without electrons, it is called anti-bonding interactions, and they are considered as a site. So wave function, because electron has a dual nature, wave as well as particle, and therefore this molecular orbital also these molecular orbitals also considered as a wave function such as psi 1 and psi 2. So if you consider this ethylene molecules, so this is your p orbital. So if you consider these p orbitals, both orbitals is in same phase. So both orbital is in same phase, and this orbital, molecular orbital is considered as psi 1, that is wave function, and the second, that is psi 2. So this function is equal to the number of carbon atoms. If number of carbon atom is 3, then the wave function is 3. If the number of carbon atom is 4, then the wave function is 4. And the second, that is both this p orbital, it is not in same plane, it is in opposite plane. So this is the case. So if you consider this p orbital, when it overlap, this p orbital interaction, so if you consider here the p orbital interaction, then the interaction of these two p orbitals, that is the p orbitals having say the p orbital are in same phase, they are results into bonding molecular orbital, that is pi bonding molecular orbital. It is considered as HOMO, and it contains both the electrons. So the pi bond is made up by two electrons, and therefore both the electrons in HOMO. But if you consider this psi 2, this is your anti-bonding interactions, and there is no electron because there is only one pi bond, so both electrons are present in HOMO, that is bonding molecular orbital. And this pi star, that is anti-bonding interaction, it is considered as a LUMO, lowest unoccupied molecular orbital. So you should keep in mind this HOMO is of higher energy and the LUMO of lower energy. If you consider in this case there is a no node, because in this case the electron density is maximum, because there is a bonding interaction, because both the p orbital in same phase. But in this case, if you consider these two p orbital, they are in opposite plane, and therefore we get here a node. So what this node indicate, the node indicate there is a zero electron density, or there is a no electron density, because it is an anti-bonding interactions. So what it indicate, there is a no electron density or zero electron density, because it is empty pi star orbital, lowest unoccupied molecular orbital is empty. So this interaction, this is your anti-bonding interaction, and the electron density is zero, or there is no electron density, and therefore it is it having a node. So you should keep in mind, that is the number of node is nothing but, so if you find out the number of nodes, which is equal to the wave function minus 1. So if you find out the node function number of nodes, then the wave function minus 1. So in this case, if you consider the psi 1, so 1 minus 1, so it becomes 0, so there is a no node. If you consider psi 2, then 2 minus 1, then it is it having a one node, because the electron density is, there is no electron density or zero electron density. So we can easily find out the nodes, and we can easily find out the HOMO and LUMO for the pi system, for linear pi system. For example, the ethylene, for ethylene, psi 1 is your HOMO and psi 2 is your LUMO, that is lowest unoccupied molecular orbit. So if you consider the anti-bonding interactions has a nodal plane, so I already told you that this anti-bonding interaction has a nodal plane, but the bonding interaction has no such a nodal plane. So why there is a no node? Because the electron density is maximum. Both these p orbital having both these p orbital in same phase, and therefore this results into the bonding interactions, and the electron density is maximum at that point, and therefore it does not have any node. This node indicate there is no electron density, and this interaction is antibonding interactions. So this is all about the ethylene molecule pi system, ethylene linear system. Let us discuss the second example of linear system, that is uh, the allyl radical is there. Allyl radical is there. Allyl radical, that is your C3H5 radical. sorry, allyl radical is there, that is your C3H5 radical. So in this case, uh, so total 3 carbon is there, so total there is a 3 wave functions, and all 3 p orbitals are involved. All 3 2p orbitals to be considered for bonding, that is in this case, in this allyl radical, in this case there are 3 2p orbital to be considered, 3 2p orbital to be considered, that is one from each of the carbon atom participating in the pi bond formation. So one from each carbon, one from each carbon. So how this interaction is going on, let us discuss it. So let us discuss this interaction. So there is 3 wave function, psi 1, psi 2 and psi 3, psi 1, psi 2 and psi 3. So this is your psi 1, so these are the p orbitals. So psi 1 does not have any node, so both these 3p orbital in same phase, so there is a no node. So this is your bonding interactions, and if you consider this is your uh, allyl radical is there, C3H5 is there, so it is denoted as like this, that is CS2 double CH, that is C3H5. In this case the double bond character is shifted, or we can say that the double bond characters, all these 3 carbons having a double bond character. This is your psi 1, so there is no nodes, so this is your bonding interactions, and we get this is your pi, that is 2 electrons are involved in these bonding interactions. If you consider this allyl radical, it having 1 pi bond and 1 radical, so total 3 electron is there. So you should keep in mind this C3H5 having a 1 double bond and 1 radical, so total 3 electron is there. So 2 electrons involved in bonding formation. Then the psi 2 is there. If you consider the psi 2, then there is a 1 node, so you should keep in mind, that is 1 node should be there. So we can write this as, this is your, and this is your node, okay, and this is your node, because what you get here, we get like this, that is CS2 double bond CS2 radical. So this is your allyl radical, is C3H5. So this is your bonding. If you consider the third one, that is your p orbital. If you consider the p orbital, so there is a node and one is bonding interaction, so we can write this as, so 2 p orbitals are in same phase, but 1 p orbital it of a different phase, and therefore there should be a 1 node and there should be no node, so there should be only 1 electron is there, so only 3 electron is there, so it is pi non-bonding, it is pi non-bonding. This is your pi bonding, 2 electrons involved in this bonding interactions, and only 1 electron is there, so it is non-bonding. And the third one, that is your empty psi 3, it having a 2 nodes, means we can write this, it having 2 nodes, so there should be a 2 nodes, so you can write this as, both p orbitals both all three p orbitals having a different are in different phase, and there should be three nodes, and it is your empty pi star orbital, antibonding orbital is there. Empty antibonding orbital is there. This is your psi 3. This is your psi 3. So if you consider, this is the p orbital interaction in case of allele system, that is your, and this is your psi 2, this is your psi 3 is the case, that is cs2 ch double bond ch2 is there. They are interconvertible. So if you consider this allele system, so there is a total 3 carbon atom, so there is a 3 wave function. Out of that, the first one is bonding interactions, that is 2 electrons are involved in bonding interactions, but there is a total 3 electrons, so 1 electron is in non-bonding interactions, and there should be only one node should be present. And if you consider the psi 3, all p orbitals having in different phase, and therefore there should be two nodes, that is the electron density is no electron density is there. So in this case it is pi bonding, pi non-bonding, and pi star antibonding. So if you consider this pi system, the lowest energy pi molecular orbital for this system have all three p orbital interacting to give a bonding molecular orbital. Higher energy non-bonding molecular orbital, in which the node is present, it bisects the molecule through a central carbon atom. So in this case, the p orbitals on central metal atom does not participate in the molecular orbital formation. So if you consider, out of that 3 p orbitals, only 2 p orbitals are involved, or we can say that it is a non-bonding interactions. So the node indicate the central p orbital does not involve in bonding. The central p orbital does not involve in bonding. So only 2 p orbital is there in psi 2, because what they tell us, that is a higher energy non-bonding molecular orbital, that is pi non-bonding. The higher energy pi non-bonding orbital, in which a nodal plane is present, because psi 2 is there, so the number of nodes is psi 2 minus 1, so there is one node. The nodal plane is present, and this node bisects the molecule, cutting through a central carbon atom. In this case, the p orbital, because due to the presence of node, so this node bisects the molecule, and due to this the p orbital does not involve in the bonding. The p orbital, that is, does not involve in the bonding, that is, or we can say that the central carbon atom does not participate in the molecular orbital, that is p orbital of central metal carbon does not involve in the molecular orbital. And the third one, that is highest energy antibonding pi star orbital, in which there is an antibonding interaction between each neighboring pair of carbon atom, and we get a pi star antibonding interaction. So if you consider, this is your HOMO. In this case, this is your HOMO. So whenever a last electron is present in that molecular orbital, they are considered as HOMO. So psi 2 is your HOMO, and psi 3 is your LUMO, that is lowest unoccupied molecular orbital. So you should keep in mind, whenever we consider this allele system, the first, that is bonding interactions, second, that is non-bonding interactions, because if you consider this, the node is present, because the p orbital of central carbon atom does not involve in bond formation, and therefore only 2 p orbitals are involved, therefore it is considered as a pi non-bonding. And the third one is all 3 p orbitals having in a different phase, and they involve in bonding, uh, they involve in interactions, and which results into the empty pi star antibonding interactions. So this is all about the allele system is there. In the next lecture we will discuss the next ligand, that is 1,3-butadiene, and the remaining ligand is there, that is linear system is there. And in the next lecture we will discuss the cyclic pi system, that is p orbital interaction for cyclic pi system. Thank you.